Right, so now that we learned about mass balance equations, how to derive them from a generic form to the final equations, let's think of how to solve those or how to use those equations solutions to solve different problems. So here is example one. This example is about the pollutants coming in the systems, that's over here, mix in a stream, this area, and then leave the systems. We did these questions before in a derivation form, but now we have example with a different term. So I already read these questions. You can spend probably 30 seconds to read it while I describe those equations. So this is again within this is a control volume. It has storm coming in, storm water coming in with certain concentrations and flow rate. Then in the upstream you have certain concentration of pollutants, and then also you given a flow rate. And you can see over here they are mixing at this point. Once they mix, you know that the flow rate in the upstream will be sum of what's coming in. So that's why already is written here. The one thing that's missing is here, the concentration in the effluent. And it says there is no reactions. That it says it's an inert or conservative substance, but there is no reactions. If there is no reactions, you can write that. And then it also says steady state. So the way you start this solution is if you know the formula, you can write it. But if you don't know, still you can solve it by writing the generic formula. The generic formula is dV dC over dt of a system would be Q in, C in, or minus Q out, C out, plus a reaction term. But here I just write reaction term because I know that there is no reaction term. And then this is a steady state, so this will be that. Once you write this term, then you solve it. Q in, C in would be Q out, C out. So let's say what's coming in. Coming in is the storm. So that will be QSC, CSC. Then this is also coming in. Q stream, CS stream. What's leaving the system is the outflow is Q mix and C mix. Well, we asked what's the C mix. So C mix would be QSC, CSC, QST, TST divided by Q mix. Q mix, you know, based on the equation here, it will be QSC plus QST. So everything else is given, so it's very easy to calculate. So if you write this one, QSC is 2000 liter per minute times concentration is 1.2 gram per liter. QST is 2 meter cube per second. So here is an issue. This is given 2 meter cube per second. This is liter per minute. So that means you have to change into one or other form, whichever is convenient for you. So let's change to meter cube to second. That would be, 1 meter cube is 1000 liter. And then you can change to second to minute, 60 seconds would be 1 minute. So that would be 62,000 times 6. So that will be 2 times 6, 12. Then you have 4, 0. 120,000 liter per minute. So if you write this one here, Q street is 120,000 liter per minute times CST is 20 milligram per liter. So again, you have to write in terms of gram. So that will be 20 milligram per liter. Then you say 1000 milligram would be 1 gram. Divided by QSE, so that's 2000 liter per minute plus QST is 112, 20,000 liter per minute. So as you see, these are liter per minute, cancel out. Then you have gram per liter both sides, so you'll get answer with 1 gram per liter. If you solve this one, you'll find that number. So that's example 1.